All right, here it is, the last official video lecture of this course before we start really getting ready for the exam with practice tests and going over everything we've learned over this past semester. So there's just a few more things we need to go over. And the first thing, which we touched upon briefly in the last lesson, is grounding. So when you're grounding something, again, that's for electrical reasons. You're connecting something to the ground. You're connecting your equipment physically to the ground with a wire and a pole so that any electricity that's not in the circuit goes into the ground and not into your body or onto your equipment. See, if you don't have grounds, a good ground, if it's not connected to the ground, then sometimes there will actually be electricity on the chassis on the outside of your radio. And when you touch your radio to change the frequency, you get a little zap. So that's why we ground things. So the local electrical codes in your area, those are what will establish the grounding requirements, which should make sense because grounding has to do with electricity. So when you're grounding something, what you'll do is you'll have this sort of rod, maybe a copper rod in the ground, and then you'll have a wire running from that rod connecting to your radio or your antenna, and that's how you ground something. So when you're doing this, you want to make sure that all your connections are short and direct. You want to avoid sharp bends in the wire when you're connecting something to be grounded. Short and direct grounding connections. So otherwise, electricity may not want to flow through these wires if there are sharp bends in them. It might decide that it's too hard to flow through these wires. You know what? It's easier to just flow through this nice person. Yeah, why don't we do that? That's not good for you. The electricity might flow through your body, which is dangerous, and that defeats the whole purpose of grounding. Because the purpose of grounding is to make sure the electricity doesn't go into you, it goes into the ground, into the earth. So a flat strap conductor is a very good material for grounding. You can Google this a little more if you want, but this is what we call a flat strap connector. What I personally did, we just went to the hardware store, we went to Lowe's, and we bought this big, I think it was made of copper, this pole, and we kind of hammered it into the ground a little, and then we just attached the copper wire, and that's in that way we were able to ground the equipment. You can email me for more details if you'd like. Or your ham radio club, once you get your license, will probably be able to help you with grounding. So what about towers? You know, we talked about ham radio towers that have an antenna on top. How do we ground those? Those are very interesting. So to ground a tower, the FCC actually recommends that you use separate 8-foot-long ground rods for each tower leg. So if you have 4 tower legs, you need to get 8 4-foot-long ground rods and pound all 4 of them into the ground, and those will ground your tower. And you want to bond them both to the tower and to each other, so they're connected to each other as well. So sometimes you also install grounding devices connected to your coax cable, the antenna cable. And in this case, you want to ground them to a common plate which is connected to an external ground, which basically means you might have this main grounding thing, like a plate maybe, and all the wires will connect into that plate, and that'll go into the ground. And that's how you would ground something like that. All right, now let's move away from the subject of grounding and move into the subject of exposure. So you want to be very careful when you're dealing with radio waves because you don't want to actually turn someone into fried chicken. I'm not speaking literally, but the RF coming from your ham radios can actually affect the people around you. Similar sort of to how a microwave affects food, your RF can have some effect on people, although you're not really in danger of killing anyone or anything like that. You're not going to become fried chicken. Nothing bad is probably going to happen, but you do still want to make sure that your RF exposure, the radiation, is safe for the people around you and for you. So the frequency and the power level that you're using to transmit, the frequency and power level of your RF field, and also the radiation pattern of your antenna, the way it radiates signals, and also the distance from your antenna to people, those all affect radiation and how RF can radiate into people. So the human body is interesting. It actually absorbs more radio frequencies, more radio waves at some frequencies than compared to other frequencies. So exposure limits, they vary with frequency, the amount of exposure you're getting to RF. So we have what we call the maximum permissible exposure limit, or the MPE. And this is a value for how high the exposure can be while still being safe. So 50 megahertz, or 6 meters, that band has the smallest value. It has the smallest MPE, the smallest maximum permissible exposure limit, meaning that you cannot have a lot of exposure on that band. You have to make sure your exposure is especially low on that band because the human body is sensitive to exposure at that frequency. So technically, you're supposed to evaluate your exposure levels as if you're transmitting with more than 50 watts at the antenna. In other words, if more than 50 watts is coming out of your antenna, you need to evaluate your exposure levels. How do you do this? There are several ways. You can calculate the exposure based on FCC bulletins, which guide you through the process. You can also use computer modeling if you're very fancy, or you can just measure with calibrated equipment in order to measure the amount of radiation. So if you do find from your tests that there is too much exposure, you usually need to move your antenna somewhere else. And you also want to reevaluate and redo these tests whenever you change your equipment to make sure you're still okay and you're not radiating signals dangerously. So you do usually have to move your antenna. That's usually the thing that has to be moved in these cases. So something that's very important when we're talking about and trying to calculate exposure is what we call duty cycle. So duty cycle is just a fancy word for the percentage of time that a radio is transmitting. So for example, if you're sitting in your ham shack and half of the time you're just listening and receiving and half of the time you're transmitting, your duty cycle would be, I guess, 50%, because that's the percentage of time the radio is actually transmitting, as opposed to just being on the air or operating or listening. So duty cycle, that affects the average exposure of people to radiation, because obviously if there's a higher duty cycle, you're transmitting more, people are getting exposed to radio frequencies more. So VHF and UHF luckily use non-ionizing radiation. We call it non-ionizing radiation. So radio frequencies that you're going to transmit with your ham radio, don't worry, they're not radioactive or anything like that. There's no way you're going to cause genetic damage. They do not cause genetic damage or anything like that, unlike radioactive material. The test might ask you some more technical questions about radiation. They might, this is one sample question, in fact, you could get asked. If the averaging time for exposure is 6 minutes, how much power density is permitted if the signal is present for 3 minutes and absent for 3 minutes, rather than being present for the entire 6 minutes? So this seems like a complicated question, but it's really not that bad. So the answer to this is 2 times as much. It can be twice as dense. So if you look at this question, it sort of makes sense. See, the question says, the averaging time for exposure is 6 minutes, but you're only transmitting for 3 minutes, half that time, so your signal can be twice as dense and still make the exposure limit. And this may not be a 100% accurate way of describing it, but it's good enough for the exam, and that's the simplest way of explaining it. So either you can use your brain for this question in that way, or if you're still having some trouble understanding, you can just memorize the answer, because this is the only type of question that you're going to get asked about this. So you can just remember that the answer is 2 times as much when they ask you questions about exposure and they give you numbers. All right. There's one more important thing we need to know, and in fact, this is the last thing I'm going to teach you before we move on from the Gordon-West manual and we start actually practicing a lot for the exams. You want to be careful of RF burns. I'm sure you've been wondering this whole time what this picture is. It's been sitting up here for the past 2 lectures, and I'm just getting to it now. This guy is getting an RF burn. See, you do not ever want to touch your antenna while you're transmitting. You will get an RF burn. What is an RF burn? It's very hot, it's very painful, it's like getting electrocuted. You do not want an RF burn. So here in this car, this guy's transmitting, and I don't know why, but this guy's touching his antenna and he's getting zapped. And yeah, that's not good. So you want to make sure not to get RF burns. It can be very, very painful, as you can see.